All right, welcome AP Calculus. Let's do this. Game plan for today is to do differentiability with systems of equations. So it might have been a minute since the last time we've done or looked at systems of equations. For example, if I said, hey, you have 10x minus 9y equals negative 32 and 2x minus 10y equals 10, can you solve for both x and y? How would you solve the system of equation? We did this back in algebra. And if you feel like you can do this all on your own, great. Go for it. Try on your own. But if you feel like you need a little refresher, I got you. What is the game plan when it comes to solving for systems of equations? What you want to do is you want to get a positive and negative number. A positive and negative of the same number, so you can add both equations to cancel the variable. Okay, so we'll just break this part into three parts, right? We got 1, 2, and 3. If you want, just write this down for a quick second, or you can see it over here. Let me move my camera angle. Okay, so first what we want to do is, let's look at step 1. It says get a positive and negative of the same number. So when you take a look over here, I have a 10x over here and a 2x over here. And when I'm looking at these variables, what I want is, I wish, like if this is a positive 10x, I wish this was a negative 10x. So then how can I make this 2x become negative 10x? What I'm going to do is I'm going to multiply the bottom by negative 5. So now when I multiply this negative 5 to the 2x, it becomes negative 10x. So let's see. So the original top equation stays the same, right? 10x minus 9y equals negative 32. Now, what happens over here? What is negative 5 times 2x? That's negative 10x. Negative 5 times negative 10 is positive 50. And 10 times negative 5 is negative 50, right? And what was the purpose of getting a positive and negative, right? A positive and negative of the same number? Because what can we do? We can add these two equations. Here, when I add this, the top equation with the bottom equation, what is 10x minus 10x? This cancels. And notice that, and I'm sorry, this is a y here. Now I have negative 9 plus 50, and what does that become? That is 41y equals negative 82 when you add these two values together. And what did we accomplish over here? We only have one variable. Before we had two variables and we couldn't solve the equation, but now once you eliminated one of the variables, then you just left with an equation with one variable, and you could solve this equation, because if I said, hey, 41y equals negative 82, how would I get y by itself? I just divide both sides by 41, and y is equal to negative 2, right? And yeah, you see here, we could have, and going back to the strategy, like if this is a 10x, it's easy to make this a negative 10x, because to make this 2x a negative 10x, I just multiply by negative 5. You could have canceled the y's, but it would have been a little bit trickier, because you would have had to have multiplied the top and the bottom with a different value to make the numbers a positive and negative so they cancel out. Okay, so once you get y is equal to negative 2, you could plug this y into the top or bottom equation. So, you know, it doesn't matter which one, but looking at both equations, the bottom one looks a little bit nicer. So if I go back to 2x minus 10y equals negative 50, right? What am I going to do? I'm going to plug this y in here, because I want to solve for x now. So then I have 2x minus 10, and let's put this in over here, right? This is negative 2 equals negative 50. So then I have 2x plus 20 equals negative 50. And then how do I continue? Minus 20, minus 20. Oh, whoops, pause, I messed up. Because the original equation is 2x minus 10y equals 10, my bad. Oh, sorry, I gotta do this over again. Sorry. This is 2x minus 10y equals 10, right? So then 2x minus 10 times negative 2 equals 10, right? So this is 2x plus 20 equals 10. I subtract 20 on both sides. And 2x equals negative 10, divide 2, x equals negative 5. And there it is. We solved for both x and y. Okay, and this was the idea, right? Let's just review. First, we wanted a positive and negative of the same number, right? For either the x's or the y's, and we chose the x's over here because it was easy to make this, like if this is a positive 10x, it was easy to make it a negative 10x. We just multiplied it by negative 5, right? You have to think what will make it a positive and negative. That was the strategy for systems of equations. And then once we had a positive and negative, we just canceled the variable and solved for one variable and then plugged it into one of the original equations and solved for x. And there you go. If you want, try this one on your own. Pause the video and try this question. How would you solve for this system of equation? Right. Let's say you pause the video and you want to see how it's done. Notice that you already got lucky that you already have a positive and a negative of the same value for b. So notice you don't even need to manipulate anything like we did over here. We simply, here, we could just add both equations because the negative 8b and the positive 8b just cancel. And then now I have negative 3a is equal to 6, right? Then divide both sides by negative 3. So now I have a equals negative 2. And now that once we have a is equal to negative 2, we could plug it into the top or bottom equation. Which equation looks nicer? I'm going to pick the bottom one because there aren't as many negatives. So if I have 3a plus 8b equals negative 5, I substitute a in here. This is 3 times negative 2 plus 8b equals negative 5. This is negative 6 plus 8b equals negative 5. Plus 6 plus 6. And now here, this is 8b is equal to 1. I divide both sides by 8. b is equal to 1 over 8. And it's okay to get a fraction, okay? It's not the end of the world. All right, so that was just a review because this was just algebra. So now we need to do some differentiability with systems of equations. And it won't be as bad as it looks. I got you guys. So let's turn the page. Let me get a new paper because I don't like the backdrop of it. So let's take a look at this. Let's read this question. It's saying, determine the values of a and b, which would result in the function f of x being differentiable at x equals 1. Holy moly. Okay, so now here we need to solve for both a and b, right? Now notice that if the function is differentiable, then the function is continuous. Let me write that down. If the function is differentiable, then the function is continuous. Okay, so here let's be patient with this problem. If I said, hey, what does it mean for a function to have continuity or be continuous? Hopefully by now you should be okay with the definition. If you want, please write the definition down before, pause the video and try and write the definition on your own, okay? If you want to see what it is, it'll be the limit as x approaches a of f of x has to equal f of a. But then what does this limit definition mean? That the limit from the left has to match the limit from the right. So from this, right, this is still f of a, but for this to be true, you know that the limit as x approaches a from the left has to equal the limit as x approaches a from the right of f of x, okay? And this is the proper definition of continuity. So what we're going to do over here is, if the function is differentiable, it has to be continuous. So let's plug in 1 from the left and from the right, and let's see what we get, okay? So let's see what happens. Here, we know our x value is 1, okay? So let's plug in, if I have the limit of f of x as x approaches 1 from the left, it has to equal the limit of f of x as x approaches 1 from the right, okay? So first we're going to look at continuity. Okay, so here, which part of the piecewise function represents the left side of 1, right? So if this is 1, which side is the left of 1? Will be the top equation. So notice that I have 3ax minus 1 represents the left side, and the right side, because this is saying x is greater than 1, right? The right side is represented by here. So it's 2bx squared minus 2x plus 9. Now we know that the x value is 1. So let's plug in 1 into both the left and the right. Okay, so if I plug in 1, it's just 3a, right, times 1 minus 1 equals 2b 1 squared minus 2 times 1, I know my bad, 1 plus 9. Okay. Now what happens here? Let me zoom in. So now here what happens when we plug in 1? This just becomes 3a minus 1 is equal to, this is 1 squared, so it's just 2b minus 2 plus 9. And then I have 3a minus 1 equals 2b plus 7. Okay? So now here, what we're going to do is, once we get to this position where we just have a and b, we want a and b on the left side of the equation. So why do we want this? I'll explain very soon, okay? Let's just get a and b on the left side of the equation. So notice that a is already on the left side, this 3a part, but now we just need to transfer the 2b to the left side. So then how would we do that? Notice that I want to get this plus 1 on the right side. So I'm sorry, this minus 1 is over here. So let's add 1 plus 1. And notice, what do we get? We get 3a equals 2b plus 8. But now let's move the 2b, let's move the b to the left side, right? So I'm going to do a minus 2b and a minus 2b, right? And notice what are we left with? We're just left with 3a, oops, sorry. We're left with what? 3a minus 2b equals 8, okay? And notice that this is equation 1. Okay, this is one equation. What we're going to do, the game plan is we're going to create a system of equation with 2 equations. So notice that the first equation we have is 3a minus 2b equals 8, right? And how did we do this? Let's just review. We know that the function is differentiable, so then it must be continuous. We plug in the 1 in for the x, and we create an equation with a and b on the left side. Okay, so this is one equation. So now how do we get the second equation? If we have continuity, we did continuity. Now we need to look at part 2, which is differentiability. Okay? What has to be true for this function to be differentiable? Now here, let's take a look at differentiability real quick. Differentiability. What would be the definition for differentiability if you wanted to pause the video? Right? here, you need the derivative of the left as x approaches a, right, has to match the derivative from the right as x approaches a from the right. The limit from the derivative of the limit from the left has to match the derivative of the limit from the right. Okay? So the game plan is now we need to take, before we had just the limit from the left and the limit from the right, but now we need to take the derivative of the left and the derivative of the right. So notice, you see how this 3ax minus 1 represents the left side? What would be the derivative of 3ax minus 1? It would just be 3a. Because here notice that this x part cancels, and what is the derivative of negative 1 is 0. Okay, what's the derivative of 2bx squared minus 2x plus 9? What do you think that would be? It would be 4bx minus 2. Now notice, yeah, right, because you have 2 times the 2 is 4. This b stays, x over here. And now notice, what does x equal? X still equals 1. So we're going to plug in 1 in here, but now I just have 3a equals 4b minus 2. And the same strategy we had over here, we just want a and b on the left side of the equation. So what would we do to have the a part and the b part on the left side of the equation? I would subtract 4b, subtract 4b. And now I have 3a minus 4b equals negative 2. And notice that this is equation 2. Right? And now, all the stuff we did, it does feel like a lot, but the idea isn't too bad. Notice that this was equation 1 and this was equation 2. So let's put them together. Like if I had 3a minus 2b equals 8, that was equation 1. And what was equation 2? It was 3a minus 4b equals negative 2. Imagine if I said, hey, just this. Can you solve this system of equation for a and b? And that's all you need, and then that's it. That's all you need to do to solve this problem, to see if the function, to see which a and b values would make the function differentiable at x equals 1. Okay? So this, I assume that you could almost do on your own. I think you could do this on your own. I mean, I'll show it in a second. But just to review the idea, what you want to do is you want to create 2 equations, right? So you look for continuity, the left and the right. You plug in your x value, and then you get the a and the b on the left side of the equation. So you create 1 equation. Then you do the same thing for differentiability, where you take the derivative of the left and the derivative of the right, and then you create another equation. Then you solve this system of equation. Okay? And if you want, pause the video, try and solve the system right now. How would you do it? Right? When I take a look at this, I want a positive and negative of the same value, and notice that if I have a positive 3a here, I just want to make this a negative 3a. So then what would I do? I would just multiply both sides by minus 1. So now here, this becomes 3a minus 2b equals 8. And this is negative 3a plus 4b equals positive 2. The a's cancel. I'm just left with 2b equals 10. Divide 2, b equals 5. Now that I know b is 5, I could plug it into the top or bottom equation. The top equation looks nice. I have 3a minus 2b equals 8. I'm going to plug in 5 for b, so I have 3a minus 2 times 5 equals 8. 3a minus 10 equals 8. Plus 10, 3a equals 18. Divide 3, a equals 6. And here are my a and b values that make this function differentiable. Okay? Whew. I believe in you. You can do this. It's not impossible. Try this one on your own. Or try this one on your own, and we'll review it together in class. Proud of you.